need to decide when we're storing data in our applications is whether we want to use a relational database management system or a NoSQL database. There are reasons to use each one of these, and we're going to talk about those a little bit in the next few slides. As stated previously, the two major choices are going to be a relational database management system or a NoSQL database. They're going to differ a little bit in their purpose and in their capabilities, what they're good at, and what they're maybe a little less good at. So a relational database management system is typically going to be something that's local. It's going to be something that's hosted nearby where your web server is. Maybe it's on the same machine as your web server. And these typically are going to be used for targeted purposes, often operational purposes. And compared to a non-relational data storage, these are typically going to be a little bit more large scale. They may be distributed over several locations. We often use a non-relational data storage system to deal with lots and lots and lots of data that may be stored in multiple locations, may be generated in multiple locations. But oftentimes we don't necessarily need to look at all of this data together, or we don't necessarily need to look at all of this data in a consolidated or aggregate way very quickly. Whereas a relational database management system, this is usually going to be closer to our web server. It might not be replicated or operate over large geographic distances, or if it does, or if it is accessed that way, we probably need really fast access to it. Relational database management systems are typically categorized by these ACID properties. They usually use this acronym to describe the fact that there is atomicity, consistency, isolation, and durability in these databases. So atomicity basically means that we can treat operations or sequences of operations in the database as atomic. So if we need to update 3 or 4 different records and we need to do that in a single transaction, we have that capability. So we can update three or four things, and if any one of them fails, we can cancel the whole transaction. So the purpose of that is, if I'm updating 2 bank accounts, one to move funds from one and one to move funds into another, you want to make sure that is a transaction that actually works and that occurs or is undone completely, so that you have the sort of the security of the financial data there. It's not you're not losing any money anywhere. Consistency is this idea that any execution of any of these transactions is going to make sure that the database is still consistent. So we're still able to access the data. We're not half writing records. It's still the database can still be queried normally. Isolation is the idea that all of these transactions can happen simultaneously, so they don't affect each other. And then durability is the idea that once we execute an update, or once we execute an insert or something to actually put data into the database, it's going to stay there. So it's durable, that data is persistent. We don't have to worry about whether or not the system's going to crash and we're going to lose data. So those are all very good capabilities of a database system, but the problem is that they take time and they take some level of synchronization. So they're not necessarily super fast, and when you get into broad geographic distances, sometimes that can be a problem. If you have users all over the world updating your systems, the speed of light tends to be an issue. You can only move data around the globe so quickly. So sometimes a centralized relational database management system isn't really the best option. Sometimes it is. Sometimes it has a really good purpose. Sometimes you need these capabilities. But non-relational data storage or NoSQL systems tend to often be popular, especially in the context of the global web. So the idea behind these properties, the base properties, is, which is kind of a forced acronym, I think, just to correspond to ACID. But, the basically available means that it is, it should be available, but, we're not guaranteeing that all of the data is available 100% of the time. More or less what we're saying there is that we believe that it'll be there. We should have backups. We should be able to access this, but it's not necessarily going to be available all the time. Soft state means that the state of the database may not be perfectly consistent at any given moment, so we might have to as opposed to consistency of the ACID type of database, soft state means that state may be evolving. And eventual consistency is this idea that eventually the data will settle, or eventually we'll get to the point where things will be consistent, but it's not necessarily guaranteed in real time. And if you think about this, sometimes for certain types of data, we're going to want to guarantee the things that we get from an ACID database. But other times, we might not be so concerned about having exact states of our data. If we're dealing with financial transactions, we might want an ACID database for the consistency and the durability that provides. But if we're dealing with something like a Facebook update, if you have Facebook updates coming from all over the world, you might not care too much if one of those doesn't make it into your news feed right away. Similarly, if you have something like views on a YouTube video, you probably don't care too much if it's 307 views versus 312 views, as long as that comes through eventually. So sometimes that type of system can be a little bit more effective for these purposes. So how do we decide to use one of these or another? Well, I think that the joke in programming and in software engineering is that half of the answers to interview questions is hash table. Half the time, if you just say hash table, then you're probably going to be right. But if the answer isn't hash table, then almost all the other answers are it depends, and that is because it depends on a lot of different factors here. So you need a relational database if you need strong transactional support, or if you need an enforced structure of your data. One of the nice things about relational database management systems is that they allow you to set very specific guidelines on the types of data. Relational database management systems work really well when they're focused in a particular region, or you have very fast access to the data from whatever you're accessing it from. Large size is probably pretty important. You can go up to a few terabytes, or hundreds of terabytes sometimes. And if you need SQL access, so SQL is a structured query language, and it's a pretty common way to store, update, retrieve, and delete data. It's a language in and of itself, but it's it allows you the capability to interact with data in a pretty effective way. Now, NoSQL, typically you're going to look at this if you need sustained performance, and that the performance aspect is more important than the atomicity, consistency, or isolation features. You also might want to use a NoSQL system if your data requires a flexible structure, or a flexible structure, sort of lower enforcement of the data that you're actually going to store and the way that it's going to be stored. If that's okay, that might be a better way to go about it. Broad distribution of the location of the data. So if you're building a global application, it might be more effective to be able to store that in different places around the world. So NoSQL might be effective in this way. And if your data has a very large size, beyond hundreds of terabytes, then a NoSQL database might be more effective. So just going over those ACID properties again, atomicity basically means that we can execute series of queries, and they can be, and the updates can be treated as a transaction. So, if we need to execute 7 different updates as part of a sequence, we can fail all of them, or we can unless we make sure that they all operate. Consistency, the data is stored in a reasonable format. Storage is not corrupted from update to update, so as we update the data or update our database, we don't have to worry about whether or not the database is going to be left in a stable state. Isolation basically means that we can operate multiple transactions or multiple queries independent of each other. And durability means that we are persisting data in a way that allows it to maintain consistency and access even if the database has to be restarted. The base properties are that the system basically available. The system does not guarantee that operations will be available or remain consistent. This has to be managed within the web application or within some other application, however that data is generated. Soft state, as stated previously, the state of the database is not perfectly predictable. You don't necessarily know exactly where things are, but with eventual consistency, after some time the data is consistent. Maybe not immediately, but you make an update and your query might not see that update right away, but eventually, with some given time that will be available. So this should give you an overview of relational database management systems and NoSQL systems. We're actually going to use a NoSQL system for the purposes of this class that's also built into Google Cloud and will allow you to access it very quickly and very easily. So we'll get into that in future videos. We're going to talk a little bit more about basics of data before we get to that. But for now, thank you for watching.